All right, it is Friday afternoon, and so if I make any mistakes, make sure that you call me on it on Tuesday. So be watching for mistakes, make sure that I'm actually doing the right thing, and make a little note to yourself. Oh, Mr. Jesperson, I think you're wrong here. And so make sure that you are watching carefully. Indirect measurements. We're looking at how do you measure something if you can't directly measure that. And that sounds really weird to say, but what I'm talking about is if you were trying to measure like the length of an entire road, you would not take a ruler and just start measuring the road, right? That would be an awful way to do it. You couldn't even take like a tape measure and measure the length of the road. So we have to find another way of measuring things. If you want to measure a skyscraper, or really just any kind of a building that's more than about 24 feet tall, we can't really take a ruler or a tape measure and make the tape measure go that tall. It's just really hard to do. And so we have other ways of finding that measurement. We're going to do that in an indirect way. So you'll often see these types of problems on standardized tests, on MCAs, on ACTs, on SATs, all those alphabet soup tests. You'll find a question very similar to this. They like flagpoles. They like buildings and trees and stuff. So a flagpole casts a shadow that is 75 feet. My screen just went black, so I'm waiting a second here. All right. Flagpole casts a shadow that is 75 feet long. At the same time, a 6-foot tall man casts a shadow that is 9 feet long. Write and solve a proportion to find the height of the flagpole. On the test that you will have on this, I am going to require, and it says in bold on the test, you must draw a picture. You absolutely have to draw a picture for these problems, even if you can do it in your head. I need you to be able to draw a picture. Your pictures luckily do not have to be good. I am not going to grade you on the quality of your artistic ability, but you have to draw something that represents a flagpole. Done. That's it. That's all you have to draw. Don't make a big deal out of drawing a picture. I've drawn a picture of a flagpole. The flagpole casts a shadow. Done. Really, this isn't that bad. You're going to draw a picture of a flagpole that casts a shadow that is 75 feet long. What's essential for these pictures is that you label them correctly. One of the biggest reasons why we have these pictures is so that we can label them. They don't have to be the right size, they don't have to look good, but you have to label it. So we've got a flagpole that casts a shadow that's 75 feet long. At the same time, a 6-foot tall man. So here's going to be my 6-foot tall man. Now you'll notice that my man and my flagpole are actually fairly close in size. That doesn't really matter. Our pictures don't have to be to scale as long as they are a picture that represents what we're talking about. So a 6-foot tall man. So my man here is 6 feet tall. 6 feet. There we go. Okay. And he casts a shadow that is 9 feet long. Okay. So there's my 9-foot shadow. Now, if you are artistic and you want to shade and you want to draw in 3 dimensions and you want to make this look really good, do the math first, then go back and be artistic. I have no problem with you being artistic. Please be artistic. However, do the math first. Then you can go back. All right, so I've got my 2 pictures here, and I want to know the height of the flagpole. So that's my unknown. So I'm going to use x feet. I don't know the height of the flagpole. Okay, what I've got here essentially are 2 triangles. And we just dealt with triangles. We just did a whole bunch of problems that dealt with similar triangles. These are similar triangles. They're both right triangles. And there's other things that go on there that we're not going to get into and how you can decide if they are similar or not. But at this point, you can assume, and I'll tell you that they're all going to be similar triangles. The math behind that you'll get to in geometry as a 9th grader. However, for now, you're just going to have to trust me that these are similar triangles. And if they're similar triangles, that means we can set up a proportion between their sides, just like we did in the last notes. So I can set up a proportion. I don't know x, and I do know 75. And so we can do x over 75 equals, so I'm looking at this triangle right here, x over 75. And over here, I have to be very careful to make sure I'm setting things up the same way. I went from let me use this color again. I went from vertical over horizontal, x over 75. So I'm going to do the same thing with my man. Vertical over horizontal, So I'm going to go 6 over 9. I have a proportion. I can solve that proportion. I can cross multiply, and so I get 9x. And again, you can use a calculator if you need to for these, but I'm going to because it's Friday afternoon. And so 75 times 6, 450. Probably could have done that in my head, but not today. So 450. I divide both sides by 9, and I get that x equals 50 feet. And if we look back at my picture, that seems to make sense. The shadow of the man was longer than the man is tall. The shadow of the flagpole should be longer than the flagpole is tall, 50 feet. Okay, we solved for the height of the flagpole. And again, we could not have taken a tape measure and measured 50 feet. So we found another way by comparing those similar triangles, by comparing the length of those shadows. So we got another one. Forest ranger is 150 centimeters tall, casts a shadow that's 45 centimeters long. Okay, so here's my forest ranger. There we go. Ambiguous. We don't know if it is a man or a woman. So we've got a forest ranger who's 150 centimeters tall. So I'm going to label that forest ranger, and we know that they have a shadow that is 45 centimeters long. Again, obviously my picture is not to scale, but it doesn't matter as long as it's a picture. At the same time, a nearby tree. I'm going to use green because I can. Here's my tree. That's not too bad. The tree casts a shadow that is 197 centimeters long. Sorry, 195 centimeters long. Write in self-proportion to find the height of the tree. I don't know the height of the tree, x centimeters. And again, you can use whatever variable you want. I'm going to use x. Now I can set up a proportion. Again, I don't know x, but I can write x over 195. So x over 195. And I got 150 over 45. And I got to go in the same direction. If I'm going to do vertical over horizontal, I can do vertical over horizontal, and I get 150 over 45. So again, I'm going to get 45x equals, and I'm going to pull out my handy-dandy calculator again and see that 150 times 195 is going to give me 29,250. And then I'm going to divide both sides by 45 to get x by itself. Divided by 45, divided by 45. Again, make sure that you are showing your work and not just writing down the answer. 650 centimeters. And we've got our height. And again, if we look back at the picture, the man was taller than the shadow, and the tree is taller than the shadow. So we've got a reasonable answer. Last one here again, please do pause at any time. Try it on your own first. Honestly, I encourage you to try it first on your own before you watch me do it, so that way you can check your answers and make sure that you are doing it correctly, but try it on your own first if you can. A woman who is 5.5 feet tall casts a shadow that's 3.5 feet long. So now we have got a woman. They've got a little more hair for this one. I don't know why she has more hair, but she does. Pigtails in this one, I guess. A woman who is 5.5 feet tall, so I'm going to label 5.5 feet tall, casts a shadow that's 3.5 feet long. There we go. I labeled my picture, and again, absolutely have to draw a picture. It's going to be graded on the test that you draw a picture, get practice at it, but it's really important that we do it so that you can get a visual idea of what's going on. There's a lot of numbers and a lot of things as to where they are, and if you can draw a picture, you get a much better idea of how everything is related to each other and how these two triangles connect. Okay, at the same time, a building, all right, let's go with, there you go, building, casts a shadow that's 28 feet long. There we go, 28 feet long. Again, my artistic ability is awful, but it's a picture. And it gives us an idea of where things are. If you want to be more artistic, please do, because my artistic ability is bad. But it gives me an idea of what's going on in the problem. And that's what I need you to do, is to get a visual idea of how things are related to one another. All right, we can set up a proportion. Again, I'm going to go vertical over horizontal. You don't, in fact, you know what, I take that back. I'm going to do it the other way. Let's see what happens. I'm going to go horizontal over vertical. Why not? 3.5 over 5.5. Let's be crazy. We'll go horizontal over vertical. And then again, horizontal over vertical. I'm going to go 28 over x. Wow, so radically different. It's nuts. We're going to cross multiply. We got 3.5x equals, now if you did it the other way, if you did pause it and try it on your own and you did it a different way, just wait. Don't change anything, because I bet you'll get the same result I do. 5.5 then times 28, 154. In fact, there are 8 ways to set up this proportion correctly and still get the correct answer. Yeah, pretty sure 8 ways. And then I'm going to divide both sides by 3.5. 3.5, 3.5, and x is going to equal 44, and I need to label my answer 44 feet. A lot of feet. And again, I look back at my question. The girl was, or excuse me, the woman was taller than her shadow, and the building is taller than the shadow. It worked. All right, it's 44 feet. That is the height of the building. So that's what we're looking at. We're drawing pictures, we're creating these triangles, and we're using some indirect measurements to get the height of buildings, flagpoles, trees, that we wouldn't normally be able to measure without these similar triangles and these proportions. Try this problem, 154, number 48, draw a picture, see if you can get the result that you want, and we'll do some more problems in class.